Engineering 305, Chapter 4, Problem 19. The stresses on the free surface of a bar subjected to an axial force P and a torque T are shown in figure 419. So regardless of what they're doing with T and P, we get the stresses shown on that square. Now I've got a shear stress of 5,000 psi and a normal stress in the x direction of 8,000 psi. You know, I got space over here. I'm just going to write that down. Shear is equal to 5,000 psi, and my normal in the x is equal to 8,000 psi. All right. The bar is made of steel, so I know my Young's modulus and Poisson's ratio. Let's keep writing. Let's just keep writing. E equals 30. Instead of KSI, I'm going to write MSI. Instead of 30,000 KSI, I'm going with that. And that was the lamest Poisson ever, but I'm sticking with it. 0.3. Determine the strain components. Strain in the X, strain in the Y, and the shear strain in the XY. All right. Now, this whole chapter has been about Hooke's law, Hooke's, how we do this. Well, let's get rid of these let's get rid of the problem statement and show up the study guide equations. And so now the first question we have is, do we have plane stress or do we have three-dimensional stress? Well, it was on the surface. It was on a free surface. I think I said that by accident. Oh, the free surface. That means there's no stress in the Z. So we can go back to this is plane stress, and we can use these equations to come up with the strain in the X, the Y. What were we asked for? The strain in the X and the Y and the shear strain. So we can get the strain in the X and the Y because we know Young's modulus and we know the strains, and so we can do that. We can do that. That is what we've got. So behind the equations, I'm writing my equations. The strain in the X is equal to 1 over Young's modulus times the stress in the X minus Poisson times the stress in the Y. And now I'm going to make that go away. Oh, you know what? I'll write the other one too. I have to solve for strain in the Y equals 1 over Young's modulus. Strain in the Y, or stress in the Y minus Poisson times the stress in the X. And I did need to write that, so okay. Make that equation go away. There. Now those show up, and I got my values over here on the side. So if I want to find my strain in the X, this is equal to 1 over 30 MSI times what the stress in the X was equal to 8,000 PSI. Well, that's good, minus, and we're going to keep going, minus Poisson times the stress in the Y was equal to 0. So my units are going to cancel out, which is good because my strain is dimensionless. So strain in the X is equal to 8K over 30M. Because my PSI canceled out with my MSI. I had to keep the M, but you got that. And so then if I calculate that out, I have 266 micro. It's my strain in the X direction. Strain in the Y direction, actually easier. Well, this term goes to 0. And so now it really looks very similar. Strain in the Y is equal to 1 over Young's modulus. But now it's times negative Poisson times sigma X. So really I've just changed that value. I throw an extra 0.3 in there, which is equal to 30 MSI on the bottom here, and an 8 KSI and a 0.3, and I got to put the negative in there. And if I calculate all that out, I get, negative 80 micro inch per inch. I don't know why I wrote as E negative 6 that time. Now, does that make sense? 266 times 0.3. Yeah, that's pretty good. That's pretty good. I can buy that. Okay, lastly, the last term, and I got to go pull up the problem statement. It asked us for strain in the X, strain in the Y, and the shear strain. Well, what's my shear strain? Well, come on, you got to go back to our equations, and it isn't one of these study guide equations here either. It's actually above that, and it's a little bit more straightforward. G is equal to the stress over the strain. I got to put my XY coordinates on there. But now I have to calculate G, which is equal to E over 2, 1 plus Poisson. I got to check that equation. E over 2, 1 plus Poisson. Yeah. And so I have to calculate that. And then, well, my tau is given right here. That was right out of the problem statement. And so, sorry, I have to rearrange this. Gamma xy is equal to tau xy divided by G, but I'm going to substitute in E 2, 1 plus Poisson. And that whole thing becomes negative 433 micro. Okay. Ta-da! Good? Good to go? Trying to shrink it. There, I shrunk it. Probably too much. There's no making everybody happy. There you go. Hope you're doing well. Don't worry, there's more to come.